All right, I'm going to start my presentation about the timing and trends in vegetation greening indicate increasing plant available water in the Rio Santa basin in the Peruvian Andes. Of course, this work is a team effort, so I put all my colleagues here. Yeah. Okay, so we are located in South America, in the Andes. The Andes range is here, and particularly we're looking at one specific valley, the Rio Santa basin, which is this part here. It's very high elevated, so the valley floor would be something ranging from 2,500 to over 4,000 meters, and the highest peak, the Huascarán, is way over 6,500 meters high, and you have a lot of glaciers, although being very close to the equator. The rainfall regime in the region is characterized by very high rainfall sums in the Amazon basin, and at the Pacific coast you kind of have more like a desert, and plants would only grow from water which comes from stream from the upper parts. And our valley is right at the transition, so to speak. So the very high mountains block a lot of this precipitation, which means that the eastern slopes receive more precipitation than the western slopes. We can also see that here, where we have rainfall observations we set up in the past years on this transect, visible here. And you can see that the highest rainfall sums are found on the eastern side. Also, from this rainfall regime, you can easily notice that there's hardly any precipitation in the northern summer month, while the northern winter month show a lot of high precipitation sums. This means we have a distinct dry and wet season in the region. And we were looking into this in our research project in many ways. So the background of a study of my colleagues was that that farming, which is mainly rain-fed in the Peruvian Andes, is increasingly threatened by climate changes, but also economic changes. And when they did interviews with farmers, the farmers reported that that they experienced these challenges, but when my colleagues looked at meteorological records of rainfall, they wouldn't find any changes or trends. However, this data is very uncertain, and there's very little data availability. This is also visible on larger scale. This is like observations, and this is some satellite rainfall data set. And you can see from global coupled models that there's a high disagreement between the observations and the models. So clearly there's a need for better understanding the changes in rainfall. And in our projects, we did a lot of different things, including monitoring crop growth. We run weather stations. We do carbon and water flux measurements using eddy covariance, and also mobile measurements with different crops to also better understand the water usage side of the whole thing. But as you all know, we are in the middle of a pandemic, and since 2019 we couldn't continue our field work, and therefore we did the most obvious thing. We looked from space, not like this guy, but using indices from satellites. In this study particularly, we used the well-known Ndvi, which calculates from the near-infrared and red band, and correlates with plant health or plant greenness. So here would be an example of a spectrum from May and August from MAIS. This is Sentinel data, but just about the concept. And over the times of a season, here's an Austrian example, you can see there's a clear seasonality in this signal of NDVI. So we compared this NDVI seasonality with the rainfall data, and you can clearly see both show this distinct seasonality of the wet and dry season here. But there seems to be a certain time shift between the two signals. And if you just look into the picture on the picture on the background, you can see that here the vegetation is really in the dry state, and there's not very active. So this photo was taken somewhere in this period, for example. And if we go a few months further, you can see in the background the vegetation in the region totally changes, and we would be somewhere in this region. But it's not only about this seasonality. If we look closely, you can also notice that there's intra-seasonal or interannual differences between the amplitudes of the signals. What we first looked at was, okay, over the 20 years of MODIS observations, how did NDVI change? So this is kind of mean annual values for the whole domain of the Rio Santa basin, and clearly there's a strong positive trend in the NDVI values. That's the first thing we noticed, and then we thought, like, okay, we have this covariability between rainfall and NDVI. So let's check what other rainfall data sets say. So the first one here is CHIRP's data set with a quite good spatial resolution. It's a data set. It's a remote sensing data set. Works like precipitation is estimated from remotely sensed cold cloud duration, and then meteorological station data is added to that. So, but CHIRP's data wouldn't give us a similar trend as the NDVI data did. Even worse for the iMerge data set. This is radar remote sensing, and it's kind of the for meteorologists, it's kind of the most or the closest data to actual precipitation measurements, but it's not very suitable for trend analysis due to some methodological constraints. I'm not going into detail here, but this gives us a very strong negative trend, which really is unlikely. And looking into some station data, we found we cannot either see any significant trends. So this is an example from the weather stations, how it would look like. Okay, so we have kind of a strong disagreement between the vegetation and the rainfall signal here. So let's dig into it a bit deeper. And the next thing we would look into monthly trends here. So the small maps are the trend pixels for the valley for each month, and the small insets, these are the domain mean CHIRP's data. And without going into detail on all the little maps, what is really visible that we have a really strong trend in the dry season months. So from May to August, you can clearly see that, like, the precipitation sums here is, let's say, somewhere 25 millimeters, and here maybe 5, and here 3. So very little amounts compared to the other month where it can be, yeah, hundreds of millimeters. And this is exactly where we find the trend. And the CHIRP's data set to some extent also represents these trends, but still it remains a bit unclear what exactly is happening here. So what we did next is look into land surface phenology derived from exactly this NDVI data. It works like this. you have this time series and this seasonal curve of Ndvi, and there's a lot of methods, but you would derive in a kind of arbitrary way. You would define a start of season date, look for the maximum and define an end of season date. In our case, the start and end would just be like 30% of the seasonal amplitude. By the way, as this is a Synseco presentation, thanks a lot to Santi and Jochem, because they supported me a lot with their software in doing this. And this resulted in these little maps here. So for the start of the season, we can see there's quite some variability in the valley. Also for the end of season, and the length of season really makes this visible. So the length of the season would be the difference of the two. And here you can really see this rainfall gradient I mentioned earlier. So you have way longer seasons on the eastern slope where more rainfall is to be expected. We also looked into trends of this data, and while the start of the season would not show any trends, the end of the season shows a strong positive trend, which is widely spread over the valley. And this indicates that there might be an extension of the rainy season over this time. So rain is also the plant available water is higher. And this also matches really well the observed dry season greening trend I showed before. For the length, we would only find small trends, although you might think at this point that this end of season should be represented here. But if you look at the small insets here, which is the domain mean of these pixels here, you can see there's a very high variability in the start of the season, and this really governs also the signal of the length of the season. To further show this, here I used all these pixels and plotted them in a kernel density estimation. And there you really can see the high variability in the start of the season over these years. So we are talking more than 2 months between different years here. So it's a very, very high variability with lots of implications. If you think of rainfall farming, people have to find the best sowing dates. So this is really challenging in a way. The peak of the season and the end of the season, they have less variability, but as I mentioned before, the end of the season has a positive trend. Okay, so now we know there, or we kind of revealed that there are trends and changes towards more water availability or a greener dry season. But so far, we really don't know what are the driving patterns of that. And in the region, what is really important for the overall climate variability is El Niño Southern Oscillation. I'm not going to explain it in the detail, but you can ask me later if you're interested. Here's an example of a strong El Niño event. I'm sorry that this is a German figure, but it's really nice, so I used it. And this is a strong El Niño event, and what would typically happen is that you have dry anomalies in the Amazon basin, but wet anomalies on the Pacific coast. And as I mentioned in the beginning, the valley is exactly located in between these two extremes, and therefore we really wouldn't know what might happen. So to have a look at this, I plotted the anomalies of Ndvi, so the deviation of the long-term mean on monthly base here, and also some index for the El Niño. So red areas would refer to El Niño events, and blue areas to La Niña events, which is exactly the opposite pattern of this year. And yeah, if you look into that, you can really see, okay, there seems to be some response somewhere, and you can find some patterns, but it's really not linear, and this is somewhat to be expected because these El Niño events, they vary quite a lot in their extension and location. So what would happen is in our valley that you can experience both dry and wet anomalies during this time. So it's not really hard. It's not really easy to say if what might happen under one of these events. However, we clearly can see that this oscillation between La Nina and El Nino events will not cause the trend. So it cannot explain the trends we found. Another way of looking at that would be just to use the monthly data and categorize it regarding to these events. And what we interestingly found is, although precipitation sums, or in especially dry season precipitation, is mostly higher during La Nina events, so we would have lower water availability or lower annual rainfall sums, we really find a higher early season NDVI during El Nino events, which is it's kind of, at first this was really unexpected, but as during El Nino events rainfalls seem to appear earlier, plants can really profit from that in the early season, while in the peak season the differences are neglectable, as water availability is not the factor which really limits plant growth at this point. Yeah, and this is kind of, it's most pronounced for this NDVI seasonality, and this is the 3 rainfall data sets I showed before. For the observations, you also can see this signal quite well, but for all rainfall data sets, the variability is quite high. So, okay. So, in summary, what we found is that in situ and satellite rainfall data in the region often suffers from inconsistencies, and trends seem to be incoherent, and so there's a lot of problem related to this data. And by using NDVI from 20-year MODIS time series, we can really reveal a robust picture, and with a high spatial resolution, and can really show changes in water availability in this time. The greening we found, and also the delayed end of season signal, indicates us that there's an increased plant available water over this observation period. With the El Niño Southern Oscillation, we cannot explain the observed greening, and as kind of an outlook, farmers really could profit, or generally agriculture in the region could really profit from medium range forecasts of this high variability in the start of the season, to find better sowing dates or crop choice. Thanks.